Hi guys, welcome to our video on predicting changes from chemical equations. So here we'll actually take a look at chemical equations and figure out what's going to happen if we did this in lab. We'll need our notes, which is our pen and paper. So again, we'll predict those changes from chemical equations and we'll kind of see what information is available in chemical equations. So here in our chemical equation, we have HCl aqueous plus Cr solid produces CrCl2 aqueous and H2 gas. So here we know that if we were going to do this in lab, we're taking that aqueous state of matter, hydrochloric acid, putting it into a solid chromium. From there, we can tell that that chromium will actually dissolve because it's CrAq, and that H2 will bubble out or form a gas. So let's take a look at a picture of what would happen here. Indeed, we're adding in the hydrochloric acid to the solid chromium. Here, we see little bubbles that are forming. Those bubbles are going to be hydrogen gas that's being coming off, and then we're left with chromium 2 chloride at the end. So let's take a look at a bunch of physical changes that can occur and the chemical equations that show us that. So with physical changes, I have the same molecular formula on each side. So I have C12H22O11 on both the reactants and the product side, but my states of matter are changing. So if I just saw this chemical equation, I know I have sucrose, C12H22O11, solid, and then that's forming aqueous sucrose. So when I see that, I know that aqueous means water, so I must have been adding water to my solid sugar in order to dissolve it. If we look at the picture, that's what we're doing here. We have this pan of water, and we're adding sugar to it. At the end, it's just sugar and water fully dissolved. On the right hand side, my chemical equation is telling me that I have that same sucrose that formed from before, and it's forming solid at the end. So I have AQ forming a solid. So in order for sugar water to form just sugar, I need to evaporate or drive off all of that water. I can actually add heat to do so, and that's what they did here in the picture. And I can form that or show that by putting a triangle on top of the arrow. That triangle represents heat. So here in the picture, heat evaporates the water and leaves just solid sugar. Here are some more physical changes. I can take that solid sugar and then continue to heat it up and form liquid. So this is what we do when we make candy. We just take sugar, heat it up slowly, and then it starts to become more liquidy. From there, we can, if we let it sit in that pan, it actually ends up cooling to a solid, so we end up having a liquid to a solid. So a physical change is just going to have the same formulas for the reactants and products, but different states of matter. Here in the equation here, we have H2O liquid produces H2O solid. We in the North Country know that if you just put a glass of water outside in the winter, it will solidify. And that's just going to be a physical change. Here I have I2S and I2G. So if I take iodine from my lab, I can actually heat it up slowly in order to make it become a gas. It skips over the liquid phase, so this is actually sublimation. When I go from a solid straight to a gas. I can add some heat to bromine so it can go from a liquid to a gas. I have in this container what would have been liquid bromine, and now it's it's changing its state of matter to become a gas. And my equation shows me that I still kept Br2 in there, I just changed the state of matter. Other physical changes can be dissolving. So other than changing the states of matter, I can also dissolve, so I can end up forming ions. I can take HCl and put that into water to form H plus aqueous and Cl minus aqueous. I can form ions at the end. And these, again, changing the state of matter and dissolving are just going to be physical changes. Here I have CuCl2 solid. If I add that to water, I will produce Cu plus 2 aqueous and 2 Cl minus aqueous. Cu plus 2, copper is a transition metal. So when I add it to water, it actually turns that beautiful blue color that you see. Now let's take a look at chemical changes. I have on the left-hand side sucrose, but on the right-hand side it's broken up. I have carbon and water at the end. So this indicates that this reaction will be a chemical change. So here, if I take that sugar and put it on the heat and actually just leave it there on high heat, it's going to decompose or break down into carbon and water vapor. And this smells disgusting, by the way, so don't do that at home. So for chemical changes, reactants have different formulas than the products. So these show 3 different examples of chemical changes. The first one has sodium and chlorine produce NaCl. So I originally started out with sodium plus chlorine, that plus sign right there, and I combined them together to form solid sodium chloride, which is table salt. Here I have CH4 gas added to O2, and when I add an organic compound like CH4 to oxygen, I know that I can actually undergo combustion, which produces CO2 and water. Here I have potassium chlorate, KClO3. It starts out as a solid, and then we can actually have that break down or decompose into just KCl, potassium chloride, and oxygen. And that oxygen will actually end up having a gas. There are also times when I'll have no reaction. So if I take that burnt sugar, which is just carbon and water now, and I try to add some more water to it, it won't end up producing anything. So pretty much what's left over here in the pan, after we burnt that sugar or drove off all that water, is just solid carbon. If I try to add water back into there, that carbon will just kind of stay at the bottom, and there will be no dissolving or no chemical reaction or physical reaction that occurs here. So to summarize, chemical equations help identify different types of change, and we can predict what's going to happen during the chemical reaction by looking at the equations. So have a great day, guys. Take care.